Okay, so welcome back. Today we're going to be talking about how to use those trig ratios we just found to solve some pretty everyday problems. So just like multiplication and division, trig ratios have an opposite function. So addition and subtraction are opposite functions, multiplication and division are opposite functions. There are opposite functions to sine and cosine. So what I mean by that is I'm going to do this. So let's talk about how to use these trig ratios. So a trig ratio is just a ratio of two sides. We can use that and your calculator to be able to find some missing information if we're using a right triangle. Now, again, if it's not a right triangle, you'll learn something in Algebra 2 that allows you to apply this to anything. So let's say that we have a right triangle here, though, and we'll use some distances. So let's say that we know that the distance from, let me actually mark this here, the distance from this point, which I'm going to call, I don't know, A to B, is 20 feet. And we know that we want to, let's say that we're hanging up like a pole, and we want to use a line, like a cable, to brace it. And we need to know how long that cable needs to be. So let's say that we're going to brace it 20 feet away from it, and we want the pole to be, I don't know, let's say 40 feet tall. So about 4 stories. We want to know how long this cable needs to be in order to be able to span that length, again, assuming this is a 90-degree angle. Nope, there's an easier way to do that. Oh, that's how. Okay, so we're going to be taking a look at how to use trig ratios to solve some kind of everyday problems here. So let's say that we have a situation where we need a side length, but it looks like we're missing some information that is necessary. Since trig ratios are the same, the sine, the cosine, and the tangent, for triangles that have the same angles, no matter the size of the triangle, we can use that to find some missing information. So for example, here, let's say that you're standing here. So here's you. We're going to call that point B. And you're standing 20 feet away from a building. And I'm going to call that building point A. And you're trying to brace a cable from you to the building, but you don't know how tall the building is. But let's say you do know the angle from where you're sitting up to the top of the building using something called an inclinometer that we'll be talking about pretty soon. So I know that that angle there is, let's say, 20 degrees. And I want to be able to find the length of either the height of the building or the length of the cable. We can do that using properties of the trig ratios and a calculator. So this is one of those times where you're going to need to use decimals. So the first thing that you want to do in this case is draw a picture if there isn't one, because a picture is always going to help you kind of understand what's going on. And I know that there are students who feel like they don't need to draw a picture. I'm telling you, draw a picture, even if it's just a super little tiny sketch. All right, once you do that, you want to label the sides based on the angle that you're looking at. So label the sides. So in this case, this is 90 degrees, which means this side here that's unlabeled is the hypotenuse. If this is angle B, and if I draw a line straight out from the vertex, this side is the opposite. And if I have the opposite in the hypotenuse, then the 20 feet side is the adjacent side. Now from here, I need to choose a ratio to work with to find whichever one I'm missing. So first we'll find the height of the building. So choose a ratio. based on what is needed. All right, so the ratio in this case, let's say I want to find the height, I'm going to need the opposite. I currently have the adjacent. So the opposite and the adjacent are part of the tangent ratio. So I'm going to use that to set up a problem. Set up a trig. And I need to write this whole thing out. So I'm going to write it out as tangent, and the angle that we're using is B, but I'm going to put in 20 degrees because that's what angle B is. It's going to be equal to whatever's on the opposite side, I don't know, over 20 feet. Now from here, it's going to end up being just a nice, neat Algebra 1 problem, because once we know what the tangent of 20 is, we can just multiply both sides by 20 feet, and that'll tell us what the opposite side would have to be. So one thing really quickly about your calculator when you're doing this, you want to make sure that your calculator is in degree modes. If you don't know how to tell, usually there's, I don't know if this will show up on camera, usually there's a little DEG up here in the corner. If it's one of my calculators, there's usually a little DEG that's down at the bottom. If you're using a calculator like a TID4 and you don't know how to find that, let me know. The iPhone I think is almost always in degrees, although it's a pain to use the iPhone for this, but anyway. So the first thing you want to do is evaluate tangent of 20, because I don't know what that is off the top of my head. I would be surprised if anybody here did. So the tangent of 20 to 2 decimal places is 0.3639, so 0.36 if I round. And then that's going to be equal to the opposite side, which I don't know, I'll use x for it, over 20. Now to solve this, I need to undo x divided by 20, which means multiplying everything by 20. When I multiply the right-hand side by 20, it cancels, and when I multiply the left-hand side by 20, I get, I have to hit enter on my calculator. I get 7.28 if I round. 7.28 feet is going to be how tall that is. Now from here, if you were asked to find the missing side, you could use another trig ratio. In this case, you could use either the sine or the cosine, but since it's a right triangle and you already have 2 of the sides, you can easily find the third just by using the Pythagorean theorem. All right, let's take a look at another example here. Let's say that we have a triangle, and I'm going to put this one kind of a little bit tilted. All right, and I'm going to mark my 90-degree angle. I'm going to call this C. Here's A, here's B, and let's say that angle B is, let's go with 30 degrees. And let's say that the length of AB is 40, and I want to use that to find the length of AC. So I'm just going to mark that with an X. So again, I went through the steps that you need to do in order to break this down. So step number 1 is draw a picture. So I already have a picture. Sweet. Label the sides. So I need to know which one's the hypotenuse, and then based on it being B, which one's the opposite, which one's the adjacent. So first I'm going to start at the vertex of the 90, draw a line out. Whatever side I touch is the hypotenuse. All right, cool. Now to find the opposite to B, starting at vertex B, draw a line out. Whatever side I touch is the opposite, and then the other one, the one that isn't currently marked, is the adjacent. I'm not going to need the adjacent, but looking back at my steps here again, I labeled the sides. I need to choose a ratio based on what's needed. So I need to choose a ratio that uses opposite and hypotenuse. So if I flip back in my notes, I want to find out which ratio uses opposite and hypotenuse. That happens to be sine. So I'm going to write this as the sine of, I'm just going to write it out in kind of like a blank way. You don't have to write it this way. Sine of B is equal to opposite over hypotenuse. And now I'm going to substitute some values in. So instead of B, I'm going to put in B's measure in degrees, which is 30 degrees. Instead of opposite, I'm going to put down X because that's what it's labeled as. And instead of hypotenuse, I'm going to put down 40. So now I need to solve for X. So to do that, I'm going to first find out what the sine of 30 is. So sine 30 And the sine of 30 is 0.5. This is equal to x over 40. If I multiply everything by 40 to cancel out that 40 on the bottom, this will cancel, that'll cancel. And then multiply by 40 over here, 40 times 0.5 is 20. Sorta? All right. So let me know if you have any trouble with this. This is kind of a weird concept. The math behind it isn't super complex though. It's mainly just understanding where things work on a triangle. And so there's one thing I kind of specifically left out. If you're having trouble remembering what the sine, the cosine, and the tangent are, there's an ancient old secret that's passed down from math teacher to math teacher, and that is TOA. So, meaning that the sine is the opposite over the hypotenuse. Ka, meaning the cosine is the adjacent over the hypotenuse. And then toa, meaning the tangent is the opposite over the adjacent. So, for example, here, I knew I had opposite and hypotenuse. So, opposite O, opposite and hypotenuse. So, there we go. If you have any questions, let me know. We'll be working through this, I'm sure. I hope everybody has themselves a wonderful day.